This is SpaceTime Series 27, Episode 101, full broadcast on the 21st of August 2024. Coming up on SpaceTime, oceans of water found on Mars. A new study shows galaxies in dense environments tend to grow bigger. And 3 Australian satellites arrive aboard the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have found evidence of oceans of liquid water deep under the Martian surface, enough to cover the red planet to a depth of more than 1 kilometre. The findings are reported in the Journal of the Proceedings of the National Academy of Sciences based on seismic activity observations recorded by NASA's Mars InSight lander mission, which monitored seismic data from Marsquakes and asteroid impacts. The discovery provides one answer to the long-standing question of what happened to Mars's water as the planet transitioned from a warm, wet world to a freeze-dried desert billions of years ago as the planet's atmosphere eroded into space. The new analysis shows that these vast reservoirs of liquid water are located in tiny cracks and pores in the rock in the middle of the Martian crust, between 11 and 20 kilometres below the surface, meaning it would be inaccessible for future manned missions to Mars. NASA's InSight lander was sent to Mars in 2018 to investigate the crust, mantle, core and atmosphere, and it recorded invaluable information about the Martian interior before its mission ended in 2022. InSight greatly exceeded expectations, helping to determine the planet's internal structure, the thickness of its crust, the depth and composition of the core, and even the temperature within the mantle. InSight detected Marsquakes up to around a magnitude 5, meteor impacts and rumblings from volcanic areas, all of which produce seismic waves, allowing geophysicists to probe the interior. Previous research showed that above a depth of about 5 kilometres, the upper Martian crust doesn't contain any water ice. But this new study analysed the deeper crust and concluded that the available data is best explained by a water-saturated mid-crust below InSight's location. Now, assuming the crust is similar throughout the planet, the authors argue there should be more water in this mid-crust zone than the volumes proposed to have filled hypothesized ancient Martian oceans. One of the study's authors, Vishan Wright from San Diego Scripps Institution of Oceanography, says understanding the Martian water cycle is critical for understanding the evolution of the planet's climate, its surface, and its interior. It's a useful starting point to identify where water is and how much there is. To undertake their study, the authors used a mathematical model of rock physics, identical to models used on Earth to map underground aquifers and oil fields. This let them determine that the seismic data from InSight could be best explained by a deep layer of fractured igneous rock saturated with liquid water. Igneous rocks are cooled hot magmas like granite and basalt. Intriguingly, this discovery pinpoints another promising place to look for life on Mars. That's if they could ever drill that deep. You see, there's no reason to assume an underwater reservoir on Mars wouldn't be a habitable environment for life. After all, it's certainly true here on Earth, where even the deepest mine shafts have been found to play host to microbial life. This is SpaceTime. Still to come, a new study shows galaxies in dense environments tend to get bigger, and 3 Australian satellites arrive aboard the International Space Station. All that and more still to come on SpaceTime. A new study has shown that galaxies located within galaxy clusters, with lots of other galaxies nearby, tend to be up to 25% larger than more isolated galaxies drifting through the darkness of the cosmos alone. The findings, reported in the Astrophysical Journal, are showing a constant size rule, even when accounting for their counterparts with similar shapes and mass. The research, which used a new machine learning tool to analyse millions of galaxies, helped resolve a long-standing debate among astrophysicists over the relationship between a galaxy's size and its environment. The findings are also raising new questions about how galaxies form and evolve over billions of years. The study's lead author, Aritra Ghosh from the University of Washington, says current theories of galaxy formation and evolution can't adequately explain the findings that clustered galaxies are larger than their identical counterparts in less dense regions of the universe. Ghosh says some of what theories predict and what the surveys are actually finding simply are no longer in agreement, and so astronomers have to go back to the drawing boards and try and modify existing theories to better explain the observations. Past studies looking at relationships between galaxy size and environment have come up with contradictory results. Some determined that galaxies and clusters were smaller than isolated galaxies, while others came to the opposite conclusion. Now, the important point here is these studies are all much smaller in scope, based on observations of just a few hundreds or thousands of galaxies. But in this new study, Ghosh and colleagues have utilized a survey of millions of galaxies conducted by the Subaru telescope in Hawaii. The authors then selected approximately 3 million galaxies with the highest quality data and used a machine learning algorithm to determine the size of each one. They then essentially placed a circle, one with a radius of around 30 million light-years, around each of these galaxies in order to represent their immediate vicinity in order to determine how many neighbouring galaxies were within that circle. And the answer showed a clear general trend. Galaxies with more neighbours were also, on average, much larger. The reason could be that densely clustered galaxies are simply larger when they first form, or are more likely to undergo efficient mergers with close neighbours. But then again, perhaps dark matter's the reason. That mysterious invisible substance that makes up most of the matter in the universe, yet cannot be detected directly by any current means, may be playing a role. After all galaxies form within individual halos of dark matter, and the gravitational pull from those halos is playing a crucial role on how galaxies evolve. So, for now at least, the mystery of galaxies continues. This report from NASA TV.
Looking back some 13 billion years, NASA's Hubble Space Telescope offers a glimpse of the early universe, revealing countless galaxies in a tiny area of sky. Galaxies are the visible foundation of the universe, each one a collection of stars, planets, gas, dust, and dark matter, held together by gravity. Hubble's observations give us insight into how galaxies form, grow, and evolve through time. Hubble's namesake, astronomer Edwin Hubble, pioneered the study of galaxies based simply on their appearance. He divided galaxies into 3 basic forms: ellipticals, spirals, and irregulars. Labeled the tuning fork diagram, Edwin Hubble's basic arrangement is still in use today. Elliptical galaxies are nearly spherical to egg-shaped groups of old stars that lack the gas and dust needed to form new stars. Rotation doesn't play a big part in their shape. The movements of their stars, often in long oval orbits, determines an elliptical shape. Elliptical galaxies are often near the center of galaxy clusters, suggesting they may form when galaxies merge. The best-known galaxies are spirals. The center of a spiral galaxy has a large, roughly spherical swarm of stars called a bulge. This bulge looks similar to an elliptical galaxy, but spirals differ from ellipticals because they rotate. Rotation gives spiral galaxies the flat disk that holds their spiral-shaped arms. Unlike ellipticals, spirals have a mix of young and old stars. Star formation in spirals is similar to a traffic jam on the interstate. Like cars on the highway, slower-moving matter in the spiral's disk creates a bottleneck, concentrating star-forming gas and dust along the inner part of their spiral arms. This traffic jam of matter can get so dense that it gravitationally collapses, creating new stars. Spiral galaxies are subdivided into unbarred and barred, and organized by the size of their central bulge and how tightly their arms are wound. Bars form in spiral galaxies when star orbits become unstable and stretched out. As their orbits lengthen, they create a bar. The bar grows as gravity captures more nearby stars. Irregular galaxies don't fit into one of the other categories. They are shapeless and have no symmetry or ordered structure. Irregulars may hold old and young stars, and often have knots of gas and dust forming new stars. Astronomers have expanded Edwin Hubble's basic tuning fork diagram to include galaxies that fall between his three categories. Intermediate spiral galaxies sit between unbarred and barred spirals and have a small bar. Lenticular galaxies sit between elliptical galaxies and spirals. They have a central bulge of stars and a flattened disk, but no spiral arms. Like ellipticals, lenticular galaxies don't have much gas and dust, and also have mainly old stars. When viewed edge-on, their shape resembles a lens, which is why they're called lenticular. Edwin Hubble's tuning fork was a first step in understanding galaxies and how they evolve. Observations by the Hubble Space Telescope will continue to improve our understanding of galaxies and their role in the evolution of the universe.
This is SpaceTime. Still to come, 3 Australian satellites arrive aboard the International Space Station, and later in the science report, new figures confirm July was the 14th consecutive month of record-breaking heat. All that and more still to come on SpaceTime. Northrop Grumman's Cygnus NG-21 cargo ship has successfully docked with the International Space Station, carrying fresh supplies and equipment, including 3 Australian-built experimental satellites. The launch aboard a SpaceX Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida was delayed by a day due to bad weather. And the mission suffered some initial problems once in orbit, with Cygnus missing its first scheduled engine burn due to a late entry to burn sequencing. The burn was rescheduled but then aborted when engine sensors detected low initial pressure. Cygnus deployed its 2 solar arrays as Northrop Grumman engineers investigated the issue. Eventually, they determined the pressure reading was acceptable, and they commanded Cygnus to undertake 2 engine burns, putting it on a trajectory to meet the orbital outpost's scheduled docking onto the station's Unity modules Nadir port 40 hours after launch. The spacecraft was loaded with some 3,857 kilograms of cargo. The manifest included just over 1,000 kilograms of crew supplies, 1,220 kilograms of scientific experiments. These included equipment for stem cell research in microgravity, an investigation to explore how spaceflight affects DNA repair mechanisms, and the packed bed reactor experiment water recovery series, which will evaluate gravity's effects on 8 test articles. By the way, packed bed reactors are systems using materials such as pellets and beads packed inside a structure to increase contact between different phases of fluids, such as liquid and gas. These reactors are used for various applications, including water recovery, thermal management, and fuel cells. Also aboard Cygnus were 43 kilograms of spacewalk equipment, 13 kilograms of computer resources, and 1,560 kilograms of space station hardware, including repair equipment for the Neutron Star Interior Composition Explorer, or NISA telescope. Cygnus also carried the Benar 2, 3, and 4 CubeSats built by Curtin University. They'll be deployed into their own orbits from the Japanese Kibo module by the space station crew within the next few weeks. Once deployed, the CubeSats, which are carrying experimental technologies, will orbit the Earth every 90 minutes for between 6 and 12 months at an orbital altitude of 400 kilometers. The satellites are carrying instrumentation developed by the CSIRO to test how new materials can protect electronics against the harmful effects of space radiation. They'll also test new transmitters and antenna communication systems developed by Perth-based company AVI. This latest Benar trio followed the successful orbital deployment of the original Benar 1 CubeSat in August 2021. That satellite used an innovative design which put all the satellite systems onto the one circuit board. Benar 1 eventually re-entered Earth's atmosphere and burnt up as planned in October 2022. While most Cygnus missions have been launched aboard Northrop Grumman Antares rockets from NASA's Wallops Island Flight Facility on the Virginian Mid-Atlantic coast, NG-21 is the second of 3 missions slated to launch on Falcon 9s from Cape Canaveral. You see, Northrop Grumman exhausted its supply of Antares 230 rockets after the NG-19 mission. Although the Antares is built in the United States, it uses Russian-built rocket engines and a Ukrainian-built first stage, and production of those ceased after the Russian invasion of Ukraine. So Northrop Grumman instead began developing a next-generation Antares 300 rocket, one which does not need Ukrainian or Russian components. It's slated to be ready to fly on the NG-23 mission in August 2025. But as an interim solution, Northrop Grumman contracted its NASA commercial resupply service competitor SpaceX to launch NG-20, 21 and 22 using Falcon 9s. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study by scientists at the Walter and Eliza Hall Medical Research Institute could help solve a long-standing mystery into why a key immune system organ called the thymus shrinks and loses its function as people get older. The thymus is important because it produces T lymphocytes. They're a type of white blood cell that plays a crucial role in the immune system. They're essential for good health and they're responsible for fighting infections and cancer. A curious feature of the thymus is that it's the first organ to shrink as you get older. And by the time you hit 65, it's almost gone, ending T-cell production. The new research reported in the journal Nature discovered two cell types that cause the thymus to lose its function. These cells were found to form clusters around T-cell growth areas, impairing the organ's ability to make these immune cells. The authors also discovered that these clusters form scars in the thymus, preventing the organ from restoring and repairing itself after damage. The new findings will allow scientists to investigate whether these cells can be therapeutically targeted in order to help turn back the clock on the aging thymus and boost T-cell functions in humans as they age. More details now on a story we ran earlier this month when the World Meteorological Organization reported that July was likely the hottest month on record. It now turns out July was also the 14th consecutive month of record-breaking heat. The extreme heat hit hundreds of millions of people throughout July. Globally, July the 22nd was the hottest day, with the 23rd a virtual tie. The highest monthly average July temperatures on record occurred in Japan, China, Bahrain, Greece, Hungary, Slovenia, Croatia and Bulgaria, while new daily temperature records were set in Morocco and Spain. The WMO says the spike in average global temperatures is likely due, at least in part, to very high average temperatures over large parts of the Antarctic, with temperatures there more than 10 degrees Celsius above average in some places. Programmers have discovered that using artificial intelligence-generated data sets to train future generations of machine learning models might pollute their output, causing model collapse. A study reported in the journal Nature found that within just a few generations, original content was replaced by unrelated nonsense. The authors used mathematical models to show that AI may overlook certain outputs in training data, such as less common lines of text, causing it to train itself on only a small portion of the dataset. And when datasets mostly created with AI were used to train AI models, the authors found that it degraded their ability to learn and even caused them to display repeating phrases. For example, a test using text about medieval architecture as original input eventually output a list of jackrabbits by Generation 9. Well, as we mentioned last week, Google have finally released the new AI-equipped Pixel smartphone range, and our technology editor, Alex Zaharov-Reutt from TechAdvice.life, has been playing with them.
Now, the Pixel 9 is their sort of entry-level phone, but it's got the same chip, the G4, the Tensor processing unit that the more advanced models have. It's got a 48-megapixel camera. It's beautiful design. Sort of takes design cues from the iPhone a bit, but it's a really striking phone. Now, they've got the Pro 9, which is the same size, and then they have the Pro XL, which is the largest 6.8-inch size. And so what they've done is the same sort of thing as Apple. They have two Pro phones, but unlike Apple, the only difference is the size. The tech inside is the same, and the Pro ones have 3 cameras, 16 gig of RAM. The thing that sets these phones apart from the rest of the market is the fact that Google has built AI in from the ground level as much as possible. In fact, they're still rewriting Android so that AI is baked at the core. But you now have this Gemini Nano large language model within the phone itself doing as much much of the work on device as possible. So you can be recording phone calls and see the notes and transcriptions and get insights. You can be using the call waiting, which I've had before, for the phone to be answering the phone for you, waiting in the call tree, predicting how long you wait on hold. I mean, I've had some of those things before, but it's now improved. But you also have this Gemini Live. Now, to get the full access to Gemini Live, you will need to pay a fee for that. But this is where you've effectively got the equivalent of Chat GPT, multimodal, so it can speak to it, show it things from the camera, and let it listen to music and tell you what it is. I mean, the sort of things we've had before. But now it's all being done on device, and the Gemini Live can take actions for you within apps. You do have to give it permission to look at your calendar or your emails. But Google is outwitting Apple and even Samsung. Apple's equivalent Siri 2.0 won't arrive till sometime in 2025. The other big thing, besides a new 45mm watch and the new earbuds that are able to give double the noise cancellation, but the other great thing they've launched is the Pixel Fold 2nd generation, which has the name of the Pixel 9 Pro Fold. That is the biggest screen on a smartphone. So when you unfold it, it is 8 inches. When you have it closed, it's the same as the regular 9 and the 9 Pro. And the thickness of each side of the phone when unfolded is dramatically slimmer than any other folding phone on the market. So when it's folded, it's only 1mm thicker than the traditional Pixel 9, which is quite remarkable because the Samsung Fold 6, although it is a millimeter slimmer than the Fold 5, I mean, this is dramatically slimmer, and it makes it much easier. Well, it doesn't feel like two phones stuck together, which is what a lot of the previous folding devices were. Effectively, you grab two phones, put them together, and that's your fold. So this is much more of a single phone thickness, which is an amazing thing to feel and see. But one thing that holds the Pixel Fold 9 Pro back is that it doesn't have any official stylus support, when that is something you've had on the Samsung for years and years.
That's Alex Zaharov-Reut from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.